So we saw that in permutation, selection and arrangement is given equal importance. But when it comes to combination, it is just the selection aspect. There's no arrangement. If you are picking up a team, if you are getting some item from the shop, doesn't matter in which order you are selecting, whatever it is, the end product is the same. If I happen to choose the red ball, then the blue circle and the, I was able to tell yellow, and the green circle. It doesn't matter in what order I choose. End of it, we have the same outcome, is it not? Right? So combination basic idea is counts the way of selecting a group of objects from a large set without considering the order in which they are selected, without considering the order. Okay, just the selection. So basically selecting two objects out of three distinct objects. So how many ways can we do it? And done. See, in permutation, we went to an extent of, after this, even this comes into picture because we have the variation in the position as well. Here we had spoke about vice president, president and all of that. But in this case, it's just a selection of team members. Right? How do you arrange that? Who is the captain? Who is the goalie and all of that? We are not deciding on that. We're just selecting the people. Right? Okay, this number of people are going over there. Right? Or this many things I'm picking it up. Is it not? So when it comes to selection of things and not the arrangement, we have to make use of combination. So what is the formula? So if we have n different things taken R at a time, then the combination represented by NCR or NCR, or there are quite a few other ways of representing it. So it is given by n factorial divided by n minus r factorial, the same formula as your permutation, but along with this we are going to divide with r factorial. For example, here we had 6 outcomes, right? But in combination we saw that the outcomes were only 3 because we divided with the 2, right? 2 selection. So 6 divided by 2 is 3. Don't worry, we will do few set of examples, then you will understand. Now let's select 2 objects out of 4. So selecting that will mean here n is equal to 4 and r is equal to 2. So we have NCR, or I'll directly write it anyways, we have written the formula and it's not a question or anything. So 4 factorial divided by 4 minus 2 factorial, which is 4 factorial divided by 2 factorial. So this is basically 4 into 3 into 2, so 2 gets cancelled, so we have 12 as our answer. So let's have a look. Oh yeah, I missed out, sorry. I need to divide with, this is permutation wala scenario. My bad. Along with this, I have to divide with 2 factorial. So this is 6. Okay. The program stops over here. The reason being, we are just selecting things, not arranging them. If we had to do this with arrangements, we can see that it will keep going and there are 12 possibilities. Okay, so there is a relationship between permutation and combination. So and that is nothing but, I'll rewrite all of this. NCR is equal to NPR divided by r factorial, right? It's the same thing actually. Okay, So let's do this. A similar setup, but here I have n is equal to 4 and r is equal to 3, right? 3 out of 4. And now we have 4c3, which is equal to 4 factorial divided by 4 minus 3 factorial into 1 by 3 factorial. So basically this is a simple calculation. So answer is 4, right? So as you can see, as and when we go towards selecting more things, the number of combination is reducing. And that's it, right? We don't have more possibilities. So there are 4 ways of selecting 3 objects from a group of 4. And at last, if you have to select 4 things out of 4, how all can we select? So 4c4. Yeah, 4c4 would be, there's only one way. How else can we choose this? If I have to select, there are 4 items in the shop. If I have to pick all the 4 and the order doesn't matter, by default there is only one way. Is it not? So that is selection of 4 things. There's only one possibility. More than using the word way, I should use the word possibilities. There's only one possibility, right? So it's a very simple concept compared to permutation. This is quite simpler, is it not? So see to that you guys write everything. It's going to help you guys understand the concept better.